In the silent, uncharted realms of our universe, a class of celestial bodies roams freely, far removed from the warmth of any star. These enigmatic objects are known as rogue planets. Unlike the familiar planets that orbit suns in stable systems, these free-floating worlds drift alone in the cosmic void. But what are these rogue planets, and what secrets do they hold? Join us on a journey as we unravel the mysteries of these wanderers, exploring their origins, characteristics, and the possibilities they present for life in the universe. Rogue planets, also referred to as interstellar planets or nomadic planets, are defined by their lack of a stellar host. They do not orbit a star. Instead, they traverse the cosmos on their own, often at incredible distances from any source of light or heat. Estimates suggest that there could be billions, or even trillions, of these worlds in our Milky Way galaxy alone. This astonishing number highlights the complexity of planetary formation and challenges our understanding of how planets exist and evolve. Most planets form from the gas and dust surrounding young stars in a protoplanetary disk. As particles collide and coalesce, they build up into larger bodies. However, rogue planets can originate in a couple of intriguing ways. One possibility is that they form in the same manner as other planets, but are later ejected from their home systems due to gravitational interactions. These interactions can occur during close encounters with other massive objects, or through the chaotic dynamics typical of young star systems. Imagine a young solar system filled with multiple planets, all competing for space and stability. As these planets interact gravitationally, some may be flung out into the cold depths of space, becoming rogue planets. This process not only reshapes the system but also highlights the dynamic nature of planetary formation. The expelled worlds carry the remnants of their formation, including atmospheres and geological features, but their isolation raises questions about their ability to retain warmth and support life. Another fascinating theory posits that rogue planets can form in isolation. In regions of space where conditions are conducive, such as dense molecular clouds, planets could coalesce without ever being part of a star system. These planets would have unique evolutionary trajectories shaped entirely by their environment rather than the gravitational influence of a nearby star. This suggests a diversity of formation processes that challenges traditional planetary science. Rogue planets can vary significantly in size, composition, and temperature. Some may be small, rocky bodies similar to Earth, while others could be massive gas giants like Jupiter. The isolation from a star means many rogue planets are cold and dark, but some could retain heat from radioactive decay or residual warmth from their formation. Recent studies have indicated that these planets could even maintain liquid water beneath thick atmospheres, suggesting that they might support forms of life unlike anything we have encountered before. The potential for rogue planets to possess thick atmospheres is an exciting area of research. Some scientists theorize that these planets could develop substantial atmospheres that insulate them, allowing for unique weather systems and chemical reactions. This possibility leads us to a tantalizing question. Could rogue planets harbor life? If so, how might that life differ from what we know? The very existence of life in such harsh environments would push the boundaries of our understanding of biology. The quest to discover rogue planets is well underway, utilizing advanced astronomical techniques. One of the most promising methods is gravitational microlensing, which occurs when a rogue planet passes in front of a distant star, bending and magnifying the star's light due to its gravitational field. This phenomenon creates a detectable signal, allowing astronomers to infer the presence of a rogue planet. So far, This technique has led to the discovery of several rogue planets, unveiling a hidden population of these elusive worlds. Future missions promise to enhance our understanding of rogue planets significantly. Instruments like the James Webb Space Telescope will enable scientists to study these worlds in unprecedented detail, analyzing their atmospheres, compositions, and potential for hosting life. With the right technology, we may one day observe the faint glow of these planets, gathering insights into their nature and origins. The existence of rogue planets challenges our traditional views of habitability and the conditions necessary for life. If these worlds can retain heat and possess the right chemical ingredients, could they be home to life, perhaps in forms we have yet to imagine? The idea that life could thrive in isolation, far from the warmth of a star, invites us to rethink our understanding of where life might exist in the universe. The possibility of life on rogue planets is one of the most intriguing aspects of astrobiology. If they have the right conditions, it's conceivable that life could exist in ways we've never considered before, perhaps beneath thick ice layers or within warm subsurface oceans. We must expand our definitions of habitability. Life might not require sunlight, but could thrive in environments we once deemed inhospitable. Rogue planets could redefine our search for extraterrestrial life. In a universe teeming with wonders, rogue planets remind us of the complexity and diversity of planetary systems. As we explore these solitary worlds, we may discover not only more about their nature, but also about the fundamental processes that govern the cosmos. The more we learn, the more we realize how little we know about the universe's intricacies. Astrophysicists are increasingly recognizing the significance of rogue planets in our understanding of the universe. The dynamics of ejected planets can provide insights into the formation and evolution of planetary systems, as well as the potential for life beyond our solar system. Each discovery brings new questions. How do rogue planets influence their environments? What role do they play in the broader cosmic landscape? Moreover, rogue planets may contribute to our understanding of dark matter and the gravitational interactions within galaxies. Their presence, or lack thereof, could offer clues about the distribution of mass in the universe, helping us to unravel some of the most profound mysteries of cosmology. The interactions between rogue planets and dark matter could shed light on the unseen forces that shape our galaxy. The existence of rogue planets also invites us to ponder their cultural and philosophical implications. In literature and art, these wandering worlds evoke themes of solitude and exploration. They serve as a metaphor for the unknown, igniting our imagination and prompting questions about our own existence in the cosmos. What does it mean to be alone in a vast universe? How does the search for other worlds reflect our search for meaning in our own lives? From science fiction to philosophical discourse, rogue planets inspire us to think beyond our solar system. Films, books, and art have explored the notion of worlds adrift, reflecting our own human desire for discovery and understanding. They remind us that the universe is full of possibilities, waiting to be explored. So, what are rogue planets? They are free-floating worlds, drifting through the universe, carrying with them the potential for new discoveries and the promise of life in unexpected places. As we continue to push the boundaries of our exploration, let us remain curious about what lies beyond our solar system, because in the depths of space, anything is possible. Thank you for joining us on this exploration of rogue planets and the mysteries of free-floating worlds. If you found this journey as fascinating as we do, be sure to subscribe for more insights into the wonders of our universe, where every discovery leads to new questions and every mystery invites us to explore further.